And welcome to our webinar today. This is all about electric floor heating, the fundamentals of electric floor heating. I'm your host with the mostest, Julia Billen, owner here at WarmlyYours. And my lovely sidekick here is Scott. Scott, introduce yourself.
She always gets choked up when she says lovely because she knows she's lying. But I'm Scott, and I'm from WarmlyYours too, coincidentally.
Absolutely. We love this. You've been with us
A decade
or more. And so truly an expert on radiant heating. And the reason he's such an expert is, one, brains and beauty, but two, Scott leads our tech support team. So he's taking all the calls, he's getting all of the things that happen in the field. And from that, we learn a lot. And we're going to be sharing that with you today. So since we've got the man here, don't forget to ask the questions. We got a lot of questions in advance. We'll be going over some of those. For those of you joining us today, we love you. We love our peeps. We love our following. But we are recording this as well. And so we'll be sending it out to the 200 or 300 or at least 1 million people who subscribe to this.
1 million.
1 million. All right. So don't forget to ask questions along the way. So let's get started. So most people are familiar with heating. Right? Fireplace, the sun. But radiant heating uses a different type of technique, a different application. And what we're used to is forced air. We're used to HVAC systems. They're in every household in America. And that's using a type of heating that really involves airflow. We're actually heating air. We're pushing it in to rooms, and it's escaping out of rooms. Does that sound about right?
And also it's a convenience thing because a lot of people use forced air heating because they want to have central air conditioning. And really the only way to get central air conditioning is to build a forced air conditioning system. So one of the downfalls with that type of system is in the Midwest where we are, and East Coast, or any place that has a basement in an area that can get cold. A lot of times the heating vents are located above your head, and what happens is that hot air blows down into the middle of the room and then goes right back up to the ceiling, meaning your feet are going to be freezing. And you can see there by the forced air heating drawing there that you can see that the blue area represents what the real temperature of the room is. Down at the floor, it's going to be chilly.
That's the cooler air.
Yeah. And the good thing about the radiant heating that we talk about is you get that in your basement floor, in the flooring surface, and that way it heats the whole area nice and evenly. It also lets little kids play down on the floor if you have children, that sort of thing. So it takes that chill off of that floor.
Excellent. So let's talk a little bit about radiant technology. We're gonna get a little bit of a spectrum thing going here. But in general, radiant technology, it's a transfer of energy, a transfer of heat, but it's not just being blown in, blown out, or escaping out. It's more about the waves of energy and heat, in this case, warming the objects in the room, and how those objects absorb the heat and then how they release it back into the environment. Talk about that for a moment.
Well, if you are looking at let's just take a quick look at this drawing on the picture on the slide here. Usually, if you talk about the sun is going to be giving off all kinds of different waves. There's only a few bits of that wave that we actually see. And if you look here, some of that's visible light, obviously the light that we can see and lights up our daytimes, but also there's the radiant heat, which is what you feel when the sun hits you. So it sends a whole bunch of this stuff out, and part of it we can see, part of it we can't, part of it's other stuff that we can't even sense. But what we are actually talking about now is not the visible light part, but it's the radiant heat part. It's far infrared, and that far infrared actually gets into you and warms you up. It also gets into the objects in the room and warms them up. So it's unlike hot air. Hot air doesn't really get past your skin or doesn't get into the couch or whatever you're sitting on. But radiant heat does. It goes in, and those waves get in there and they warm you. So one great thing about this radiant type of heat is that you can actually keep your thermostat turned down and just heat the areas that you're going to be sitting in that particular time. Also, great thing about heating a bedroom or an extra bedroom or maybe a basement is that maybe that basement's really only used 3 times a year for holiday events or for family gatherings. Well, there's no need to heat it to 70 degrees when you can just keep the heat turned off in the basement, and then when people come, you turn it on and you warm up that section. So that's what's really good about radiant heat. Infrared, far infrared heat is it warms you more efficiently, it warms you better, and you can zone it, which is really great.
Excellent. I think that's a great overview. Thank you. So that's the heating technology, and a lot of people aren't familiar with this form of heating. But once they get familiar with it, once they experience it, they really understand the quality of this type of heating. Because there's a lot less air movement, you don't have to worry about allergies. You don't have to worry about dry electric shocks, dry air, scorched air, we call it. What you really get is, especially since this is in the floor, you get a floor that's warm, and then that energy starts to move into every object into the room, and you sort of get a 360-degree bubble of comfort, if you will.
Right, exactly.
Okay, so that's the big picture. Let's move in a little bit, and first thing that we like to talk about when people are interested in applying radiant heating to their particular home is, are you going to be using this as comfort, or will this be your sole source of heating? Most of the time, people already have a home, they already have an HVAC system in place. So most of the time we're looking at comfort heat. I want to provide my home, my room, the people in my home that I love. I want to provide them a level of comfort that we're not getting right now with our forced air system. It could be the comfort's not there because maybe that's a room with a lot of heat loss. Or it could be that maybe it's not getting as much of the airflow, might be, or it could be a room that's just really hard to heat.
Something over a cold garage, something like that.
Right.
When we talk about sole source of heat versus comfort, comfort is usually a lot of our businesses. People want to step out of the shower in their bathroom and they want their feet to be warm.
Exactly.
As simple as that. People just want to get out of the tub and they want to step on something warm. People are checking their makeup in front of the mirror. They just want their feet to be warm.
And your makeup looks stunning
today. Thank you. Well, my feet were very warm this morning. So what you're going to try to determine is, do I want comfort? Do I want my feet to be warm?
Right.
Or is this a new room or a remodel or something like that I want to possibly see if this will work as the only source of heat in that space?
Right. And let's not forget, you also can combine. On some controls, you can actually combine you can select a primary and secondary heat source. So you could actually have floor heating as a primary heat source and your backup heating system, traditional HVAC forced air system, as a backup, just in case there's a very cold day and you can't seem to get enough heat into that room.
Right.
So the key there is just determine that. That's your path. If it's comfort heating, it's easy. You're going to get out of the. You're definitely going to have a warm floor. If you're looking to actually have a heat source, then we need to get a little more technical. We need to talk about BTUs, British thermal units, and we want to understand the size of the room. We want to really work with you to design the heating so that we're getting as many watts, therefore as many BTUs into that room as possible. And we make that pretty easy. We have an online calculator. You can see it right there, guys. It's the third bullet point, where we'll really walk you through with the software, and we can have an account manager right there with you as well. We'll walk you through what's all the information you need to gather to make sure that this can be used as a sole source of heating, or if there are some periods of time where it's not enough BTUs, not enough watts, we can talk to you about what additional heating you might want to have in that room. We don't like any surprises, so
right.
This is the way to make that happen.
We know that what you're going to do is very, very simple. It is rocket science, but the interface with you is very, very simple. All you're going to be saying is, my walls are this tall, my ceilings are this high, my walls have this R value insulation in them, I have this many windows in the wall. Because what you need to think about is, when you're talking about sole source of heating, there are certain items in a room that are really detrimental to sole source of heating because they contribute to heat loss. And that's what the heat loss calculation is being done on the space. We need to find how much heat will be lost in this room so we know how many BTUs are needed to heat it. And will our product supply that number of BTUs or more? Because if it's the same amount or more, we know that you're going to be comfortable 365 days a year. If it says you need 2,000 BTUs and our product can only give you 1,800 BTUs, that means your product will probably be the sole source of heat on all but 1 or 2 days. The 1 or 2 coldest days of the year, you may have to turn your towel warmer on.
There you go.
So it's very, very simple. So all this calculator is going to tell you is that tell us about your 4 walls, tell us about your ceiling, tell us about what's under the floor, and tell us how many windows you have. Because what you really need to think about is what kind of rooms are successful with sole source of heat and which ones can be problematic or a challenge. And challenging rooms have skylights. They have lots of exterior wall windows, lots of exterior walls. They could go over an unconditioned space, which means the space down below the floor is 20
Cross
degrees.
space.
Right. So all those things are what let heat escape. Those are heat loss items. So if you have any of those items, you can go, you know what? I've got a room that's 4 walls. They're surrounded by other rooms in the house, and there's no exterior windows, and there's a kitchen down below, and there's a kid's room upstairs. That room is going to be very, very easy to heat.
Right.
The other rooms that have fireplaces, skylights, exterior walls, windows, exterior doors,
Very
those are
tall
going to,
ceilings.
yeah, and very tall ceilings. Those are going to be more of a challenge.
Right.
So that's just a simple thing to keep in mind when you're thinking about sole source of heat versus comfort.
And I'm living proof that you can use electric floor heating as a sole source because I live in Illinois. I own a electric floor heating company. Every room in my home is heated with electric as the primary heat source. I don't even use my HVAC system as a supplementary heat source. And even with Chicago winters, I've never had a problem using electric floor heating as a sole source. Now that's me. I'm a little bit of a different breed. Most of what we do as a company, the large consumer segment out there, is really remodeling. They're really looking for it as a form of comfort.
So we're talking about electric floor heating products, so why don't we take a look at them?
Love your idea. Let's do it.
It's blue, it's silver, and it's green. Okay, we can go to the next.
Okay.
No, it's not that simple.
It's a little superficial. We might want to have a few more details here.
So the slab heating cables there on the left, you can see there are cables in there, also the cables mounted on mesh. And the great thing about the mesh is it keeps the cables spaced exactly 3 inches apart all the time. So you know you have a nice even heat and you can run it out, you can cut it and turn it around and make it go into that space you're going to heat. Now this type of product needs to be put in when you're talking about pouring a new slab. So if your slab is already there, then you're going to talk about the other 2 items on the slide. But if you haven't poured your slab yet, you're going to have the items on the left.
So major additions, new constructions, we're looking at slab heating.
Right. The good thing about the slab heating cable is that it can be done at different spacing. It's not always at 3. It can be 4. It can be a little bit closer just to do whatever you want it to do. So the thing about the mesh versus cable, you'll also see there's a similar type idea going on the right side of the slide.
I see it.
The items that are usually mounted on mesh are going to be a little bit more expensive, but they're going to be much quicker to install. The loose cable is going to be a little bit less expensive, but it's more time consuming to install because you literally have to string it back and forth yourself.
Yeah. Now, which do you find more flexible, the cable or the roll mesh product?
The cable lets you get into areas that are rounded or oblong, different sizes and shapes because you can kind of do it as you're out there. Otherwise, you'd have to do a lot of cuts and turns of the mesh. But if I know I'm going to be doing a big rectangular space, give me the rolls all day long because I just roll them out, cut them and turn them. I'm always cutting the mesh, never the cable, turning them, and then I can lay out hundreds of square feet much, much quicker than doing the loose cable. Yes.
Excellent. So new construction additions. Now, the middle of the slide there, the Environ product, is a product a lot of people aren't even aware of, that you can actually warm floors under carpet, laminate, any type of floating surface, luxury vinyl, tile as well, potentially. This is a great product. It comes again in roll and mats. You'll see that throughout our entire product line. And the reason for that is mats, you can really, almost like a blanket, cover a very large space very quickly. Just lay that rectangular
mat,
however you want to call it, down. The rolls, that's that provides the flexibility. You can roll those out. You can actually cut that aluminum, never the heating element.
Right.
And you can then again turn and start to design the area that you want it to fit.
Yeah, like if you take a 6x10 Environ Easy Mat, you can literally install 60 square feet of floor heat in about 30 seconds.
Boom.
Because you just lay it out and you run the cable over to the wall and you're done.
So
What's great about the Environ product in the US is that it can actually go between the pad and the carpet, so we get the heat really nice and close to your feet. So that's a really good thing about the Environ in the US of A, is that you can actually get it nice and close to your toes.
And when it comes to carpet applications, we like to share that you definitely can shampoo those carpets. You just want to make sure that the heating element is de-energized. There's a few ways you can do that. You can shut down the thermostat. You can click off the breaker in the box. So you just need to make sure it's de-energized, let the carpet dry as you normally would, and in a few days, re-energize, and you're back in business.
So that's where we talk about, that can also be used with floating wood, with laminates, that sort of thing.
Absolutely.
And we talk about then the product on the right, which is the Temp Zone. The Temp Zone is a product, once again, you can see the cable mounted onto the mesh, and it's spaced evenly, so you get nice, even heat. And we had a question asking about this particular slide, and that was from Robert.
Yeah, was he wanting to know about wet
locations?
location.
Yeah. So
yeah.
The product on the left, the slab heating, is okay for it's tested and listed for wet locations.
Mm-hmm.
The product on the right, the Temp Zone, in the cable and in the mesh are both wet location listed in the United States
Absolutely.
and in Canada, which means it can be used in showers. It can be used in a curbless shower design with wet bathrooms. That whole thing can be used under a shower bench.
Mm-hmm.
Another great application for that. So it can also be used under hardwood and wood and other popular flooring materials besides that. So it's really, really very flexible.
And that's what I love about our product line, is you basically can warm any flooring type. What are we going to talk about next? I think next we're going to talk. Let's focus on the head pin. Mm-hmm. We have a question as well. Can two Temp Zone mats be linked to one room on the same thermostat all day long? Absolutely. They're just wired in parallel to that same control. There are some limitations to how many watts/amps you can put on a control. We'll talk more about that later, but it absolutely can be done and is done quite routinely.
You can do it to your heart's content up to 15 amps.
There you go. That's the bottom line, folks. Mm-hmm. So let's hone in on the Temp Zone product, because most people are installing these types of products in bathrooms, master bathrooms, the kids' bathrooms, if they want to brag to their friends and family. The powder room's a great place to put this product, but it's usually in a master bathroom. And so that would always be the Temp Zone product, because there it is a wet location. And so let's talk about what you like about each of these products. You have the roll and you have the cable. You can use either, but when would one decide roll versus cable?
Well, if you want to do 15 watts per square foot, then you've got the roll all day long, because it's already spaced for that. So if you're going to be doing large spaces and you want it to be the maximum output, then you use the mats. If you want to, let's say that you are in an area that is not a challenging place to heat, like it's above a kitchen and it's below a heated area that's above you, then you know that you're not going to have a lot of heat loss. So what you can actually do is you can take the cable and you can space it at 4 inches apart instead of 3. And what that does is it uses less electricity. It costs less to buy up front. So I know in your basement, we did a job in your basement where we actually are over a insulated concrete slab, and we took the cable itself and spaced it at 4-inch wide spacing.
Yeah, it's a large room, so I didn't have enough electricity, so I wanted something a little more flexible. So I took the cable, just spaced it a little further apart, insulated the slab, and we'll be talking about that very shortly. And as a result, I could get something that was warm, efficient, but I used less product and I used less electrical. I also like to share that if you're in a somewhat of a warmer climate, I'm originally from Baltimore. We don't know winters like you guys know here in Chicago. you know, then you could consider spacing your cable a little further out because you don't need as much heat and as fast. But I do like to always recommend that if you're doing a master bathroom, that's a place where you're cold. You might not have as much clothing on in that bathroom. So you want to pack in as many watts, as many BTUs as possible, because you like to be a little warmer in that room. So I always like to go with the higher, if we have the electric available, the higher watts per square foot product. So that's kind of my take on it. So we have a question. Laminate will not warrant over electric floor heating. Only water-based systems are recommended. There are laminate companies that will void their warranties if you put electric floor heating over their products. We are working on that issue with laminate companies. What you will find for many of them is that they will allow it if the heating element is embedded. And so we'll talk about that. Actually, it might be the next slide or two.
Yeah, this is a very popular slide. We got lots of questions about this slide.
But if you embed the product, you then have a better chance of getting the manufacturer to certify that. Interestingly enough, many of these manufacturers will warrant wood and laminate under hydronic radiant heating, which is using pipes with warm water. They'll actually warrant under hydronic, but they're less familiar with electric. And in the number of years that we've been doing this, 20 for me, over a decade for Scott, that just doesn't make sense to us, because with electric floor heating, you can actually control the temperature to a greater degree than you can hydronic systems. Hydronic systems can swing.
Overshoot.
Okay, overshoot, and right, and so they can overheat and then underheat, and so.
So what happens, just to encapsulate kind of what you said there, what happens with hot water heat is if you ask it to be at 80 degrees, when it comes out of the boiler, it's going to be 85. So your floor is really going 85. Then down to 80, then down to 78, then right back up again. So it's always doing this. Up. That's what overshooting and undershooting is.
Right.
And we all know that the water, one more point, Julie, before you go, is that we know that the water by the boiler is hotter than it is at the end of the room.
At the end of the
So we've been discussing that with flooring companies also, and usually it's just because they have never really checked into it, is really what it comes down to.
Yeah.
But there are companies that do have warranty with that. So
absolutely.
I would say you just need to look, and you can always call us, and
we can work with your manufacturer as well. So we're happy to do that.
And Sam has got a bunch of questions. So Sam, we're going to get to your questions here in just a second. Because we have some people that beat you to the punch. So those people sent in questions that before you. So I'm a fair guy. I like to make sure first in, first out. So we had Hans send us a question, said, where to place the cables to optimize the usage without wasting or using excess cable?
Go
ahead.
I can answer that one. Well, I think the first thing you should know is we actually will do the design work for you. So we've been doing this for almost 20 years. Next year will be our 20-year anniversary. We have a design team that is well seasoned, and they've seen every room type, shape, and size out there. And so they'll actually design that for you. And they'll look at how much energy is available. They'll look at what makes sense in terms of placement, because we don't go under appliances. Usually people don't walk within a foot and a half of the wall. So we really are very thoughtful in how, we go about designing these systems for you.
The one thing to keep in mind is we talk about this in almost every webinar, is that you'll get heat where the cable is and you won't get heat where the cable isn't. So the heat really only radiates about 1.5 inches laterally from the heating cable. So you can't just put it in the center of the room and expect the whole room to be warm.
It's been done. Didn't work.
Right. So that's one thing you want to keep in mind. So you want to put the heat where your feet are going to be if you're not doing sole source of heating. Another question was from Maria, and that is, how can you ensure no hot spots for a 3/4 inch thick engineered wood? That really has two responses. One of them is that you want to always make sure that the heating product is with, because we know it only travels so far from each cable, right?
Right.
So we want to make sure that the final surface that your foot hits is no further than an inch to an inch and a half from where the cable is. And we want to make sure that the cables are spaced evenly. That's going to give you nice heat. If you get the cables too close together, it will get hot. So that's how you ensure you don't get a hot spot, Maria, is that you make sure that the cables are always evenly spaced.
Excellent.
And that's why they're mounted on the mesh in the way they are, because we know they'll always be 3 inches apart. There'll be a nice even heat, and you want to make sure, even if you have 3/4 inch wood, if you get that up close to where your feet are, you can see that you're going to be within an inch to an inch and a half of that wire.
Excellent. Now, can we answer Sam's question yet?
Okay, Sam.
All right, Sam, great question. What about cork flooring? Is it energy efficient? Cork flooring is very popular. It's a sustainable product. People love that. It's green. We do heat under cork flooring. The one thing that we like to kind of make sure that you're looking at the details in terms of the insulating factor of the cork flooring. So you really want to understand what's the R value of that cork. If it's over about 1 R value, then we would tell you that it would be less energy efficient under cork than other flooring surfaces.
And you're going to see in our next few slides why.
All
The
right.
idea is to heat on top of cork, not really underneath it.
Cool.
So that's what you want to keep. So what you want to do, Sam, is see what the R value is of the cork. So if you're out there shopping for cork, you want to find something that has an R value of less than 1. Because that leads into your next question. If you put a whole bunch of R value over the heat, it's never going to let the heat out. So your energy efficiency, you're going to be burning a lot of electricity trying to get that heat to go through a barrier that you've installed yourself.
Yeah,
So,
and it'll get there, but it's going to use more energy and it's going to take more time. So back to not as energy efficient.
right. And the thing about people always bring up hot water and boilers and that sort of stuff. The amount of energy you put into a boiler, some of that actually goes out the flue and into the environment. So it's not 100% efficient. Electric is about as close to 100% efficient as you can get. Now we realize that if we have any science teachers out there, we know that as soon as anything generates heat getting to the mat, that's a little bit of loss, a heat loss. So anyway, we know that 90 in the upper 90s is going to be your efficiency when it comes to the floor, electric floor heating. So it's very, very efficient. You don't have that heat going out the flue and exiting into the environment.
Excellent. All right, so
I told you there'd be one right here.
now this is exciting stuff. What are we looking at here, Scott?
We're looking at cork or Cerazorb, which is a synthetic type of cork, actually going under the wire.
Okay.
So Sam was talking about putting cork over the wire and why and obviously
As a final flooring
as a
surface.
final flooring, and we can see why it may not be the best match, but we can see why it's so important to put insulation between the heating wire and the concrete slab.
So walk me through these colors.
Well, they're pretty. So no,
No,
but really, if we take a look at this picture, I love this picture, and I took this picture, and that's why I'm so proud of it. Is if we take a look at this sunroom, and this sunroom's at her house, we left a portion of this area uninsulated. So in the upper left-hand corner of this picture, you can see an area where there is no cork, there is no Cerazorb. If you look in the insulated area boxes there in the upper right-hand corner and the lower left-hand corner, take a look at those heat registers there. The more red it is, the warmer it is. The bluer it is, the colder it is. So if you take a look, we did this really fancy software stuff. And if you take a look in that upper left-hand corner, that average temperature there is 75.1. In the upper right-hand corner and the lower left-hand corner, that temperature is 79.1.
Which is really where you want it to be. And the key here is this is when you're going over a concrete slab.
Right.
Okay.
And really, when you go over anything, if you really want to improve your efficiency, you put something with an R value below the cable. But it's really, really needed over the top of a concrete slab. And, we have to toot our own horn here because we were pretty much one of the first floor heating companies that said, listen, you're going to get more heat. It's actually going to get warmer. It's going to get warmer faster, and you'll use less electricity if you get that wire off of the slab.
Love it. And now we're showing two products there. They both do this to somewhat the same degree. It's just a matter of cork. You're going to see that more under carpet. maybe floating wood. And the Cerazorb, you're going to see that more under tile, or if you don't have the floor height, because it's a little bit thicker than the cork. If you don't have the floor height, you're going to be using the Cerazorb.
Yeah, and the best thing is both of these products have been tested for use under tile. So you can be very confident that these have been tested by the National Tile Council. They're rated for use under tile and under flooring. So they're both very, very reliable. The great thing about Cerazorb, it has more R value. And the good thing about it is not a natural product, which means it will not cause or enable mold growth.
Excellent.
So it's really, really a great product.
All right. Now, we've talked about the floor heating products. We've talked about insulating products. Now what we'd like to talk to you about is how do they actually get installed? And there are two main methods. And we're going to talk about embedded first, which is the most popular way that you're going to install this product. Talk to me about what I'm looking at on this image here.
Well, this image is our Temp Zone product, and it's under self-leveling.
Okay.
What's great about this type of setup is we're going to, when we're done, we're going to have a warm subfloor that is going to be completely flat, which means you can pretty much put whatever you want to over the top of it because it's like a blank slate that's warm. So what you can do is you can try with, maybe we'll put some carpet down here. If I don't like that, maybe 3 or 4 years, it's in a high traffic area, I decide to go with tile. I can tile over this because I got a completely flat surface. Or if you decide to go to laminate or whatever, once again, you have a completely flat surface to put the product over the top. So this is what embedded heat is. What we suggest is you take the Temp Zone product, adhere it to the subfloor very well, because if you don't, it'll float. So you want to make sure that you attach it very well to the subfloor so it doesn't come up on you like that. And then once you get that covered, you want about 3/8 of an inch, because that's going to give you a nice warm floor that you are going to just absolutely love with the many different kinds of flooring.
Now, Larry's asking, how about a foil-based underlayment?
Foil-based underlayments, a lot of foil-based underlayment is smoke and mirror, because a lot of foil-based really don't have any R value testing done to them. So if you were really to take one of these floor, some of this stuff really isn't rated for underflooring either. So if you see a radiant barrier or radiant product like that, first of all, there usually isn't a real R value associated with it, and all of them that I've seen haven't been rated to be underflooring. So that's very, very important that when you see that, make sure it's rated as an underfloor, a subfloor product. It can go underflooring, and also see if it really has R value or not, because they'll say, oh, it reflects most of the heat. It reflects 99%. But what people want to know is this got an R value of 10 or does it have an R value of 0.1?
So check for the R value.
It makes a big difference.
All right. Good point. Thank you for the question. So there's two ways you can install the Temp Zone product. One is embedded with self-leveling. And one question that we have from Debbie is, what if it's embedded only 1/8 inch with self-leveler? And I think the correct response is, as long as it covers completely the heating element, we're fine with that. The heating element is about what, one?
Well, it's about a 16th of an inch, but the end cap is a little bit thicker, and the factory splice is a little bit thicker. But the thinner that base is, the more you're going to get the heat just going into the air. So you may not get the floor temperatures you're looking for. Also, it might stripe on you. So if you get too close to the wire, you may actually see a warmer spot here, colder, warmer, colder, warmer. So by giving 3/8 of an inch, you're creating a nice heat bed, which spreads the heat out, keeps it in the floor a little bit more than just letting it go out into the atmosphere.
What if you did a self-leveler, and then over that you installed your tile floor, let's assume a tile floor, and you're putting that then in a 1/4 inch of thin set?
Oh, sure. If you're doing that, if you're doing a tile install, that's what most people do with the tile install, is they'll put 1/8 or so just to cover the wire.
Exactly.
Then they'll come back and they'll back butter the tile, they'll put thin set down, and by the time you do that process, it ends up being right at around 3/8 of an inch.
Right.
So that's a great question, and I'm sorry that I missed that.
Right. So you can do thin set, or you can do self-leveling. The reason we really recommend a self-leveling product is The heating element is completely encapsulated.
And there's no trowel, no really sharp troweling going on.
And then if for some reason you want to change the actual flooring surface, you want to go from tile to a floating wood, you can do that easily. So it's our recommendation to do self-leveling, but I will also tell you guys the most common way this is installed is with thin set.
Right.
Okay. And now for floating products, so this is under laminate, under engineered hardwood, and under carpet. These floats between the subfloor and the final flooring surface. Anything else we need to know about that?
It's very important that when you put this in and you're looking for a laminate or something like that, the ideal thing, once again, is to see if your laminate has a pre-attached foam pad underneath.
Good point.
Because a pre-attached foam pad or pre-attached cork will increase the R value once again, and we want to make sure that that laminate product has no R value over 1. So we did have, this has been years ago, we did have somebody who just fell in love with a particular type of laminate, and they found out really what the R value was, and it was over 1. So what they did is they would not take that laminate back. What they did is they took a scraper and scraped all the cork off of the back of it, and then it was fine.
That's dedication.
That is dedication to what you chose right there.
All right. So, for carpets, laminates, engineered wood, usually a floating install. For temp zone, when you're going under stone and tile, or if you just want to have it embedded, you would use the embedded method with self-leveling, thin set.
Mm-hmm.
Good.
And what you want to do with carpeting also here is you want to make sure that the carpet doesn't get too thin. So you don't want to use like a 1/4-inch carpet because it lets it bounce too much, and you don't want that. And what you always want to make sure of is that you don't put something, what needs to happen with this particular aluminum mat is this mat needs to have a soft side somewhere.
Mm-hmm.
So if you put it against a hard wood that's over it, you want to make sure that there's a pad between the environment product and the subfloor. So there's some give to it. So you never put this between two hard surfaces. One thing to keep in mind with when we talk about environment product is nothing's ever glued to it, and it's never glued to anything.
Good point.
Because it floats. So if you just follow a couple of those simple rules with this stuff, you're going to love it.
All right. Now, this is what I was talking about earlier. We'll design the heating plan for you. The floor plan, you just send your floor plan in. We take a look at that. We make sure that the dimensions are accurate. We love to have an idea of where the thermostat is going to be located. And then we actually take a look at what's in that room. All right, where's the shower? Where's the vanity? Where's the toilet? And we want to make sure that we get optimal coverage.
Right. So we had a question from Joe, and Joe said, where would the electric supply go, and does it plug into the closest receptacle or hardwired? To answer your question, Joe, take a look at this drawing at the top, and you'll see a T and a circle. That's usually where the thermostat goes, is somewhere by the door. If you tell us to put the thermostat over by the shower, we'll do that. If you tell us to put it on the right side of the room, we'll do that. However, the design is based on where the thermostat is, because the cable that runs from the thermostat to the beginning of the mat is only 15 feet long. So if you are going to start it where the T is, that's where that triangle thing there is. So if you see that triangle thing just below it, and it says 3 feet, the triangle represents the start of the mat, and the square over in the right-hand corner, in the upper right-hand corner, is the end spot. So what you'd want to do is if the thermostat gets moved down to the lower right corner, you're going to want that redesigned so it starts in the lower right corner.
Perfect. So let us do the hard work for you. Let us do some heavy lifting. We also include in every plan, we like to talk about the electrical aspect of it. Not only how many amps or do you need, or what voltage do we recommend that you run this at, but also what is the actual operating cost? Because, and we'll talk about that a little bit more later, but it is something that we like to showcase because many people think electric, it's going to be very expensive to operate, and it's not.
Yeah, and you can see that's right down there in the lower right-hand corner.
Yeah.
Tells you what your operating cost is.
5 cents per hour.
Yeah,
right.
Very, very inexpensive. The one thing you always want to do, though, when you're getting ready to put this in is you are going to want to make sure when you get this plan that it matches the dimensions of the real room.
That's a good point.
Because we see people that we get drawings from very, very early in a design of a bathroom, and they go, well, here's where they are. Well, we go ahead and do the design, we send the product out, and the first thing we always tell people is to make sure the dimensions are matching. We hear from people, they never call and say, hey, guess what? The dimensions are exactly the way I told you, and you did it exactly the way I wanted you to. Okay, goodbye. They never say that. What
Things
happens?
change, huh?
Yeah. What they do call us and tell us is that we changed the size of the tub, and now the tub is much larger.
Yeah.
And when you start putting permanent fixtures in that you can't heat under, the more you add, the less is available space for the floor heating. So that's why if you have a tub that went from 5 feet across to 10 feet across, all of a sudden the mat that we designed for this space, it's not going to fit.
And by the way, not a problem. Engage us, engage our engineers. We will do a redesign. We turn these things around in 24 hours.
Mm-hmm.
So make sure that if there are any changes, you come right back to us. It's not going to delay your project.
Right. It's much better to find out ahead of time than it is to find afterwards.
All right. Excellent. Love that. All right. So let's break it down. So that's in general the products, how they're installed, the plans that come with it. Now we're going to get a little bit more detailed. We're going to look at the actual cable itself.
This is a twin conductor wire. So if you see the word twin, it means that there are two conductor cores very, very close together.
It also means low EMF. For companies out there that market zero EMF, all electrical products have EMF, so there's no way really to have zero EMF. Your vacuum cleaner, your microwaves, but EMF is very minimal when you have a product that is a twin conductor. So it's not zero, but it's pretty darn close to it.
Right, and that's what, as soon as you look at any wire and if it says twin conductor, it's all going to be pretty much the same stuff. You're going to make sure that you've got fluoropolymer inside there. The difference between the fluoropolymer and either kind of sheathing or protection is that it's very resistant. It's like Teflon. Teflon is like a term for fluoropolymer insulation. So it's very, very slippery. It's also very resilient, and it will not get damaged as easily as other types.
And not to toot our own horn, but we do that all day long. This is a more expensive and higher quality cable. And not everybody out there takes the time and invests more dollars into the product. And the reason that we do that is we sell direct to installers. We know what happens in the field, and stuff happens. And so we want to make sure that we have the toughest, the strongest, we talked about that earlier, product possible. And that's why we made this investment. Exactly. So make sure that if you're not dealing with us, you're dealing with something. We know there's many choices out there that you really look at what is the product made of.
And it's also, how is it backed? You'll see that our warranty is one of the best, if not the best, in the industry. So whenever somebody calls and says, what's your warranty? Always look for the word prorated in our competitors' warranties, because prorated means that if it's really, really new, you might get a lot, but if it's really, really old, you're not. It's like buying tires. So just keep that in mind. Our warranty is not prorated.
And that's why we call it the
no
nonsense warranty. All right, so now you've looked at the wire. Now, what type of wire are we looking at?
That wire is constant wattage, and simply it's because you can tell it's the way that it's designed. So constant wattage is always going to give off the same watts per linear foot.
Right.
Some people are familiar with self-regulating cable. Self-regulating cable we sell a lot of, but we sell it outdoors for doing your roof and gutters and doing that sort of stuff, because the colder it gets, the more power it uses and the more watts it gives off as heat. But with constant wattage, we know exactly what it's going to be. It's always going to give off the same amount of heat because it's always going to be the same wattage per linear foot. So we know that this is a very good product. The thing about constant wattage is, compared to self-regulating cut kind of wherever you want it to and make it whatever length you want, as long as you don't go too far. This product, constant watt, is depending on every foot of that being intact. So you want to make sure that you never, ever cut the wire, and that's exactly why.
And I would say that constant wattage, the reason why we chose that and we lead with that is because it has a longer life. It has a long life, much longer than self-regulating.
Right.
So, but in our mind, there are definitely applications for self-regulating. We support those, but indoors for floor heating, constant wattage is the way to go.
Right.
Okay. Oh my goodness, what do we have here?
We have pretty colors once again. I just love these slides that have lots of pretty colors. Ohm's law, we could probably sit here for 5 or 6 hours and talk about Ohm's law, and our eyes would still glass over, and 99% of it would go over our head. But what we need to think about is that our cable, our constant wattage cable, is designed at so many ohms per linear foot. We then work that combination with the amount of voltage you get.
Mm-hmm.
So we know that short mats have different watts per linear foot of the cable than really long mats do, because it all has to do in figuring that out. So that's why you can't just take a really long roll and cut it in half and put it in one room and then put the other half in another room, because it will overheat. If you take resistance away, current will increase.
Yes.
Which means it will get, the more you remove, the hotter it gets. And let's say that back in the old days, you used to put 2 mats together. We used to see that on occasion.
Like daisy chain them like
Yep.
Christmas lights.
And what you're doing is you're adding resistance then, and the more resistance you add, the less electricity gets through, so the colder it gets. So that's Ohm's law in a nutshell, telling you why you can't alter the length of your cable or your mat.
And we get that question a lot.
All the time.
All right. Let's go to the next slide and talk about, and this is really what we're telling you. You can't cut that that cable. And we wanted to kind of give you a little bit of the science behind it, but it's pretty simple. Don't cut the cable, right?
Right, exactly.
You can cut the return power lead, but you cannot cut the cable.
Exactly.
All right. So the next thing that we should talk about is the fact that in residential applications, you're usually looking at doing either 120 or 240 volts. For the most part, bathrooms, you're going to be looking at 120 volts. Larger areas, basements, great rooms, you may want to go to 240 volts. There's really no difference in terms of energy efficiency. It's really the same. It's just that you can get more watts on 240 volt than you can on 120 volt. But we designed that for you. If there's any question in your mind whatsoever, we're here, we take care of it. We also wanted to show you that we've color-coded our return power leads to make it very easy for your electricians in the field. You see yellow, it's 120. That's National Electric Code. You see red, it's 240 volts. So we love that plug and play.
You can never mix and match them.
That's a good point.
So our thermostats can handle up to 15 amps in 120 or in 240. The thing you need to remember is if your mat is yellow and black, you have to send 120 to the thermostat.
Good.
The thermostat doesn't change 120 into 240. It doesn't do any of that. It's a switch. Whatever you send it, it turns on and off and sends it out.
Great.
So that's very, very important. And once again, we get this question every single day. 240 is not more efficient than 120.
All right. And then if you do have, we do have thermostats. They are rated up to 15 amps. You can load about 80% of that. But if you want to heat larger areas, you don't need to put a ton of controls on your wall. You can just add a power module that gets you another 15 amps. So we just wanted to show you here that you're not, you don't have to just reduce coverage. We do have control options that will allow you to increase how much heating that you're putting in a room.
Yeah, we had a question from Robert. What's the largest square footage you can cover using this product? And by using power modules, you're increasing coverage 15 amps every time you add a power module.
Yeah.
So you can actually, the manufacturer says there's an unlimited number of power modules you can use.
Yeah, it's a very elegant solution. All right, and here's what we were talking about earlier. How much of this have we not covered?
Well, this is the 80-20 rule, and this means that if you have a 20 amp circuit breaker, you can only use 16 amps of it. You can't use all 20.
Right.
So the most important reason why we kept this slide is because our thermostats will handle 15 amps. Okay, but you can't put 15 amps worth of product on a thermostat and then put it on a 15 amp breaker.
Right.
Even though the thermostat will switch 15 amps, if you're using up to a certain amount, you're going to have to go, if you go beyond 12 amps, you've got to go to a 20 amp breaker to make sure that you are following the 80-20 rule. You can only use 80% of what that circuit is rated for.
And one thing I do want to share is that we actually will tell you the size breaker that we recommend for that room on our electrical plans. So.
And you can tell on the picture right here. You can see in the lower right and the bottom ones, in the 2 rows, those are 20 amp breakers because they're twice as wide as the other ones. So the single space are 120, the double wides are 240.
I did not know that.
And that's how you can tell the difference.
That is so cool.
So the reason why we brought this up is because if you look and your box is completely full, like you can see that there's 4 spaces in this box in the upper part of it. 1, 2, 3, 4.
I see that.
That will fit 2 double pole breakers, or it'll fit 4 single pole breakers. So you're going to want to, if you're thinking about doing a big addition or whatever, you're going to want to look in the box and make sure that you have open spaces.
Yeah.
Because that's going to be very important too.
All right. We talked about this a little bit as well. On our floor plans, we also show operating costs. But if you want to go on, if you want to on your own kind of go on our website, we have a tool. It's called the Radiant Heating Operating Cost Calculator. And you can go on there, play around. It's a very interactive tool. It'll recognize where you are actually located, or you can plug in your zip code. You can talk about which product you're interested in, the size of the area you want to cover, how long you think you might use in terms of hours the product. For example, in a bathroom, you're probably only going to have it on in the morning and in the evenings, a few hours here, a few hours there. And then we actually show you the operating costs. As you can see, we played around a little bit here with this tool, and it came down to 22 cents a day. And the reason we like to show that, guys, is once again, there is this misconception. Electric, it must be expensive. It's not. But this is proof. So if you're looking to do this, or you want to show your clients exactly what the operating cost is, this is a great way to mitigate that concern. Right. All right. Oh, this is your slide.
Yeah, whenever you buy the product, always make sure you test it before you install it.
Yes.
If you're going to be doing a big job and you know you're getting the box on a Monday and you know the job is on Wednesday, you want to open that box and test it right away to make sure that nothing's happened to it between the factory and you.
And I see this testing 1, 2, 3.
Yep. So whenever you're doing testing of this product, there's always 3 tests you have to do. From yellow to black or red to black, that's number 3. Number 2 is from black to ground, and number 1 is from red or yellow to ground. So what you're doing is you're testing for the circuit, and you're testing to see if there are any shorts.
Excellent.
So always do that testing before you get out to the job site.
And the reason you do that testing?
Because then you'll know if it's good or bad. And if something happens down the road 5 years later, someone decides, you know what, I'm going to put a door stop in here, and they drill through the floor, and all of a sudden, you know what they do? They put a drill through the wire. That wire can be repaired. The number one question we get is someone says, "Oh no, I don't know if my floor is working or not." Usually it's the thermostat.
Yeah.
Especially on older systems. But they say the first thing is, I don't want to rip up my entire floor. And the first thing I always say to them is, I don't want to rip up your entire floor either, because 99 times out of 100 you don't, or even fewer than that.
So the key to not having to repair a floor, because guys, let me just share this with you. 80% of the time, the damage to a floor heating system is done during installation. Would you say that might even be higher than 80%?
Yeah, what happens is people come in and they put tile down, and then the guy that comes back 2 weeks later to clean the grout lines with his sharp metal blade doesn't even know that there's heating in the floor. So he gets in there and he cleans out those grout lines and makes 24 cuts in the wire.
So key is to test when you get the product, during install, and at the end. And then if there is, like you said, that example, because that's after the fact, someone comes back and does something they put in the doorstop or the clawfoot tubs. We'll get that. They'll nail in the tub. We're here to help you. We've repaired a lot of floors. We have a team, we call them Zero to Hero, because it's not working and they make it work. So we have tools to send you. We have an outstanding tech support team, including this fine gentleman, and we can help you to repair those floors. And
not to worry, if your floor is damaged and you didn't buy it from us, let's say that you're working with us now, but back in the old days you sold a different product, 9 times out of 10, we can fix that product too.
Absolutely. And we do
So,
that all the time
yeah.
as well. So call us.
Yep.
All right. So any other questions out there? I think we've got a lot covered there.
Yeah. I think we've answered most of the questions that we got.
What do you guys think? How'd we do?
Any questions? We'll give you a couple minutes to think about that. Let's go ahead and talk about our next webinar while they're thinking of questions.
Thank you, Debbie. I'll take fantastic. All right. Well, join us for our next webinar. We do this every month. Usually it's the second Thursday at 1 p.m. Central Time. We're going to start to talk about heated driveways. It's been, thanks, Sam. Great. You're great too. But we're going to be talking about heated driveways. We've got a lot of interest, especially with this strong winter, a lot of snow. A lot of people are interested in our snow melting products. So join us next month to talk about that. And we always have something going on, guys, for you. We've got 20% off our Temp Zone Easy Mats. We've got a towel warmer sale at 25% off, so take advantage of it. But in the meantime, we love you guys, and we hope to see you next month. Give us some feedback. Tell us what you want us to talk about, because we actually will talk about it. But until we see you again.
You can always get a hold of us by
yeah,
phone,
we're here.
by email, by the website. Just one thing we didn't talk about, I'm going to make it very, very short, is we have tons of videos on our website. So if you have any questions about how this gets installed or that gets installed, please check out our website, because there's a ton of video content there.
Yeah. So until next time, stay warm,
Be
be radiant. Take care,
So long.
guys.